So what we're going to deal with here is an example of sort of a pretty stock standard basic titration question. Okay, so here I've labelled we've got sulfuric acid in the burette. Okay, the burette's this one up here. We've got sulfuric acid in the burette, and we don't know it's the concentration of that sulfuric acid. Okay, and that's what we're trying to work out. Okay, and then down here in the conical flask, we've got potassium hydroxide. Okay, with a concentration of 0.101 moles per litre. Okay, and we know that this is called the aliquot. Okay, so we've got an aliquot of potassium hydroxide. Okay, and our titer is going to contain sulfuric acid. Okay, so we're told that the volume of our aliquot is 25.0 milliliters. Okay, and we're told that the volume of our titer is 22.5 milliliters. Okay, so we've filled the burette with sulfuric acid, and we've used a pipette to put 25 milliliters of potassium hydroxide into this conical flask. Okay, and then we've let the sulfuric acid out drop by drop. Okay, until we've reached the equivalence point. Okay, and then we've figured out the change in volume of the sulfuric acid solution in the burette as we've released it. And so we figured out that we've reacted 22.5 milliliters with this aliquot of potassium hydroxide. We figured out that the titer volume is 22.5 milliliters. Okay, so what we're going to do now is we're going to use this volume, and this concentration to work out the concentration of the sulfuric acid. Okay, so first what we need to do is we need to write out the chemical equation for this reaction. Okay, so we've got a classical sort of acid-base reaction here. Okay, so we've got potassium hydroxide and sulfuric acid. Okay, and we know that because it's an acid and a base. Okay, it's not a carbonate though. The base it's just a regular base, not a carbonate. Okay, and therefore we're going to produce a salt. This salt's going to be potassium sulfate. And water, as always happens when we react an acid with a base. Okay, and then we know that we're dealing with stoichiometry here, and we know that the most important component of stoichiometry is to balance the equation. Okay, that's what stoichiometry is all about. So here we've got two potassiums. We've got one potassium here, so we put a 2 in front. Okay, we've got a sulfate here and a sulfate here, so we can ignore we can just kind of look at the sulfate as a whole and see that that's balanced. Okay, and then outside of the sulfate, we've got 2 hydrogens, plus 2 hydrogens gives 4 hydrogens, plus another 2 oxygens that aren't part of the sulfate. Okay, and so here we need to put a 2 here in order to get 4 hydrogens and 2 oxygens on this side as well. Okay, so now this is fully balanced, this equation. So now, what we want to know is the concentration of the sulfuric acid. Okay, and we know that the concentration is equal to the mole divided by the volume. Okay, we've got the volume here. We know the volume of sulfuric acid. We've got that. That's the same as the titer volume. So what we need to work out in order to find the concentration of sulfuric acid is the mole of sulfuric acid. Okay, and so what we're going to use to work that out is basic stoichiometry with this equation here. Okay, and so we've got, for every 2 potassium hydroxides, 1 sulfuric acid molecule is reacting. Okay, so that means mole of sulfuric acid is going to be half the mole potassium hydroxide. Okay, we know that if we rearrange this, we get N equals CV. Okay, so the mole of potassium hydroxide in the aliquot is going to be the concentration, so 0.101. Okay, and then the volume is in milliliters, but we want to have it in liters. Okay, so if we calculate that all out, okay, what we get is 0.0 0.00126 mole. Okay, so that's the mole of sulfuric acid that we have. Okay, we know this mole now. Okay, so now we know the volume of the sulfuric acid as well. So basically, we just sub this value and this value into this equation. Okay, so the concentration of sulfuric acid is going to equal. Okay, we know the mole of sulfuric acid over the volume of sulfuric acid. Okay, so the mole of sulfuric acid is here. Okay, and we know that this number of mole is in 22.5 milliliters. Okay, or 0.0225. Okay, and so if we work out this concentration, then we get an answer of 0.0561 moles per liter. Okay, so that is our final answer. Okay, so what we've done is we've pipetted. We've used a pipette to get exactly 25 milliliters of potassium hydroxide standard solution with a concentration of 0.101 moles per liter into this conical flask. We've filled this burette with sulfuric acid with an unknown concentration. We've filled it. We've checked how full it is. We've checked the volume. Okay, using the measurements on the burette. We've dropped sulfuric acid into this conical flask, and we've reacted it with potassium hydroxide, drop by drop, until we've reached the equivalence point at which this ratio was met. And then we've checked the volume of the burette again. Okay, and we've figured out the difference between the starting volume and the end volume of the burette to be 22.5 milliliters. And so that volume is the volume of the titer, or the volume of sulfuric acid reacted with the potassium hydroxide. Okay, from that, first using these two pieces of information, we figured out the mole of potassium hydroxide in here. We've used stoichiometry in this equation to then work out the mole of sulfuric acid that's been reacted with the potassium hydroxide, or the mole of sulfuric acid that was in the titer. Okay, so we've done that here. Okay, and then using this answer here, all right, we've used this answer in conjunction with the volume of the titer to figure out the concentration of the titer here. Okay, and so that is how we can use volumetric analysis in the form of titration to calculate the concentration of a solution with an unknown concentration, okay, using another solution which was a primary standard solution.